Hello, my name is Abdel Salam Abu Tabiq, and today I'm going to be presenting a boiler control system. And this is our agenda for what we're going to be talking about today in this presentation. First of all, the introduction. My control system is a boiler, which is aka a kettle. It incorporates a sophisticated control system to regulate and monitor the operation of the boiler, utilizing sensors and controls to ensure the safety and efficient operation of the kettle. My temperature target here is 220 Fahrenheit and that's how much the water is gonna boil in the kettle. My physical system design here, on the right, I have a diagram of the physical model, which consists of a base connector, a thermostat, heating element, switch, and a physical body. The boiler heats up the water from its normal room temperature using the metal plate underneath, which is known as the heating element. Once the water reaches the desired temperature, the thermostat, also known as a heating sensor, will detect it and stop the heating process. And we were aiming that the temperature after this process will be 220 Fahrenheit. My physical system design. So here I use a sensor biometallic strip and the bimetallic strip is made up of two different metals with different thermal expansion coefficients, which causes the strip to bend when it's heated. This bending action is used to activate a switch, which turns the heating element on or off to maintain the desired temperature. In my control system is that this bimetallic strip is gonna bend up and it's gonna stop the circuit and which will stop the heat from reaching to the water when the water reach target temperature. Hardware integration. To maintain consistent results and temperature levels, we will need to install a PID controller, which stands for proportional integral derivative controller. The PID controller will receive feedback from the temperature sensor and use it to adjust the control signal sent to the sensor, ensuring precise temperature regulation. The desired performance of the electric kettle should provide a smooth and precise control of the temperature level, with minimal lag and without any oscillations or overshot. So here my PID controller is going to help me get better results and help my temperature when it reaches target to stay consistent. And here, as we can see here, we can see a graph, and this is my desired output graph of temperature versus time. And if you can see here, we have that red line that goes up to 80 Celsius and stays. I know the temperature is not accurate as I want, because mine is 220 Fahrenheit, but this is the overall trend that I'm looking forward after doing my control system. System modeling. So when we're talking about system modeling, a system modeling can be approached in three different ways: physical modeling, empirical modeling, and black box modeling. For this control system, physical modeling involves I use the physical modeling, and that involves deriving equations that describe the system's behavior based on physical principles and laws. And on the right, you could see a graph of physical modeling and empirical modeling and how they work. For my continuous and discrete math, the system model can be used to adjust the PID controller. Auto tuning will be used for this purpose due to its ease and efficiency. Although it may not be most accurate method, it is adequate for this simple system. Nonlinear factors such as friction and hysteresis could affect the sensor, but they will be considered negligible for this exercise. So talking further about this point, once we have derived the system model, we can use it to tune the PID controller, which will be shown later on. Bayesian computing. So when I did my transfer function in Simulink, I got a transfer function for my control system, and I got this transfer function from doing my research online. And on the bottom, you could see a graph of my transfer function. And on the right, we could see two graphs. The first graph, the top right corner, that is the graph before we use a PID controller. And as we can see here, it oscillates and it's not smooth and constant. The the bottom right graph is my final graph, and it shows my temperature 220 Fahrenheit, and it's constant and it's smooth. And my system for this control for this project, it's a closed loop system. System development. So when I'm considering this project, there's a lot of things that could go wrong. So overshooting temperature over target, that's something that I would worry about. Adding a safety switch, that's something that's very important because we're dealing with electrical part. And manual temperature adjustment, if I could to further further improve my model, I would add a manual temperature. So let's say that the consumer, he doesn't want his water to boil at 220 Fahrenheit. He can make it boil at a different temperature as he pleases. When developing the system, we need to consider various concerns such as safety, reliability, and maintainability. And this is my presentation. Thank you all for listening.